So to start this video, we're going to just review what we learned last year about interior angles of polygons. So if you recall from last year when we did an investigation, the interior angles of a triangle, they added up to 180 degrees. And then the interior angles of a quadrilateral added up to 360 degrees. And every side that you add 180 degrees. So a pentagon adds up to 540 degrees, and a hexagon adds up to 720 degrees. So what basically is happening is you're adding 180 for each side. And we also learned a formula last year that was n minus 2 times 180, where n was the number of sides. And if you recall from last year, the reason why this happened was a triangle, you can form one triangle, and triangles add up to 180. And then a quadrilateral, the minimum number of triangles that you can form is 2 triangles. And so 2 triangles is 360. And then a pentagon, the minimum number of triangles that you can form, is 3. And 3 times 180 is 540, and so on. So if we do a hexagon, the minimum number of triangles you can form is 4. And so 4 times 180 is 720. And so basically the formula, the n minus 2 part, is actually the number of triangles, the minimum number of triangles you can form, and each triangle adds up to 180 degrees. So that's where that came from. So now if we look at this, you've just investigated this year about exterior angles, there's some things that you've learned now about the exterior angles of a polygon. If you're interested, you can click on this link here, and it will just take you to an interactive investigation. And right now you can only see half the screen because of how I set up my record screen, but this can take you to an investigation if you're interested. Just to explore it a little bit further. Based on the investigation that you did, however, you've learned that all exterior angles add up to 360 degrees. So it doesn't matter how many sides the polygon has, the exterior angles always add to 360 degrees. And so any polygon, the sum will be 360 degrees. So why is all of this important? Well, you can use this to find missing sides. So the first type of question you can get is kind of a problem-solving type question, that you know what the interior angles add up to and you have to come up with the shape. So basically what you're going to do is you're going to be working backwards from the formula. So if n minus 2 times 180 has to equal 1620. And so how do you work backwards from the formula? Well, you're going to do 1620 divided by 180, and then you're going to add 2. And when you do that, so 1620 divided by 180, you get 9, and then if you add 2, you get 11. And so that means the shape must be an undecagon. And then if we look at this picture down here about finding missing angles, again, we know that the sum of the angles in a triangle adds up to 180. We know that this is an isosceles triangle, so that we know that these two angles here must be equal. And so we do 180 minus 70, and we get 110, and then we divide it by 2, and we get 55. So that means B must be 55. And then A and B are supplementary, and so we do 180 minus 55, and we get 125 degrees. So let's look at another example. So in this example, there's lots of places that you can start. I would probably naturally start with A because these two are opposite, and so that means A has to be 45 degrees. Then I might probably find D or E because I know that those are supplementary, And so I'd do 180 minus 45, and I'd get 135 for D, and because they're opposite, D and E are equal. Then I'd probably go here and find out that C and 132 are supplementary. And so I'd subtract from 180, and I would get 48 degrees for C. And then to get B, I've noticed that this is a triangle, and the sum of the angles in a triangle have to add up to 180. So I would do A, 45, plus C, 48, and I get 93. And then I subtract that from 180, and I would get 87 degrees for B. And so here I'm applying my use of opposite angles and supplementary angles and sum of the angles in a polygon, etc. And then this example here uses the new thing that you've learned this year about exterior angles. So notice that this is a quadrilateral. Notice that these four angles are exterior angles, and we know that the sum of the angles in any polygon, and sum of the exterior angles, excuse me, in any polygon is 360 degrees. Now, I didn't give you any numbers, but we can use our algebra skills. So we know that angle A, which is x plus 4, plus angle B, which is x minus 3, plus angle C, which is x minus 6, plus angle D, which is x plus 9. We know that the sum of those four angles, because they are exterior angles, has to equal 360 degrees. Then I can collect my like terms. I have 4x, and 4 minus 3 is 1. 1 minus 6 is negative 5. Negative 5 plus 9 is 4. So I end up with 4x plus 4 equals 360. Then I use my algebra skills to solve for x. So first I'm going to subtract the 4, and I get 356. And then I'm going to do 356 divided by 4, and I'm going to get 89 degrees. So that means x is going to be 89. And then what I can do is I can substitute. So 89 plus 4 would be 93. So I know that that one would be 93 degrees. And then likewise, 89 minus 3 would be 86 degrees. So that would be this one. And 89 minus 6 would be 83 degrees. And 89 plus 9 would be 98 degrees. Also, keep in mind that the angles are not going to be drawn exactly to scale. And so you just have to go with what the math tells you, not so much what the picture looks like.